And our next speaker is Tom, going to talk about improvements in how HTCondor is managed at Brookhaven.
Screwed up the mic already.
You don't need that.
Testing, testing. Can you guys hear me? Is there a hand mic?
Quiet.
Yeah, is there a hand mic going on?
Oh,
I don't know what to do with my hand.
you can use the podium mic. You're fine, just
Grab
being
it.
stationary.
Can you guys hear me? Okay, so you'll notice that this talk is not originally on the schedule. Greg actually approached me yesterday to fill a vacancy in the schedule, and I'm more than happy to oblige. It also means I wrote this almost at this entire talk last night and finished it about 2 hours ago. So anyway, we're ahead of schedule, on time, under budget. So let's just jump right in and see what happens. So I'm not going to spend too much time on this slide, just a brief overview to give you the context of the size of the Condor pools that we're working with. We operate 3 main pools at BNL. We're the US Atlas Tier 1. We're the S-Phoenix Tier 0 for our on-site S-Phoenix experiment. And we have a more Condorly shared pool to accommodate all of our other users. Our site is on the order of about 200,000 logical cores, all told. We have about 50 or so access points and CEs altogether. And we host about 600 petabytes of physics data on site for our users to chew on. So what the talk is really about, the realities of living in a world of finite resources. This is a non-exhaustive list of some of our exhaustible resources. Of course, one that's dear to my heart is admin time. I don't have an unlimited amount of time, but we're doing a lot to increase the human throughput of our admins, such as myself. CPU time's another big one. If you can waste less CPU, you get more throughput. Number go up. You love to see it. And there's this other weird thing that people have been interested in lately, memory. So if we can quantify some of the inefficiencies, we can start to address them. And has anybody else noticed that this stuff is starting to get pretty expensive? I think so. So anyway, most people can probably relate to this, but technical debt costs time. BNL's been running Condor for probably over 25 years at this point. So we've accumulated a lot of technical debt over a long period of time. We're focused on a continuous uptime. We always want 100% uptime, bearing any power outages or things outside our control. But continuous uptime creates a focus on, you just want to fix it enough to keep running. This creates a culture of maintenance over development. Most people don't have time for both. And if you don't have time for both, then you find yourself just doing maintenance all the time. Adding any feature to the existing code base was non-trivial. There's deprecated features and workarounds just about everywhere. Workarounds for the workarounds. I found myself fighting the code that existed more than developing new code. But why now? So there's no time like the present. EL7 is gone at our site. Alma 9 is here to stay. We've gone through a long period of rapid change in development at BNL. We have a lot of powerful tools at our disposal now that we didn't have even just a few years ago. And we need to adapt to a culture of rapid change. We simply can't afford to stay frozen for many years at a time like we used to. We'll just absolutely get eaten alive by Linux vulnerabilities, and our cyber folks will probably kill me if we try to do that. So we have to get used to upgrading and updating at a pretty rapid pace, faster than ever before. So one of our big efforts in the last year was HTCondor config refactor. I went through all of the configs, no stone was left unturned. We went line by line and rewrote the whole thing. So went through all of them. Some lines were moved to a different level. A lot of deprecated things were just removed entirely. Just get them out of here. Some very old code existed to provide things that are now amazing first-class features. So I love to see that. That was very satisfying. A lot of lines that we had explicitly in the code match the default. If it matches the default, it doesn't have to be there. So in a lot of cases, we just simply removed it. Values that didn't match the default were, of course, scrutinized. These Condor guys kind of know what they're doing, and defaults are defaults for a reason. So If we're not matching the default, we have to figure out why, and ideally provide a comment that explains our reasoning. Comments were added in general. A lot of our code is not super well commented, and that becomes a problem if you're maintaining your own code or maintaining someone else's code. And old syntax transforms were transformed, and that's going to be necessary going forward, especially in Condor 26 plus. So if you still have old syntax transforms, do yourself a favor and update them sooner rather than later. And after this work, the total size of our configs by number of lines was reduced by more than half, and this includes the new comment lines added. So probably the stuff that does the actual work is maybe a third or even a quarter of the size of what it was before. So a little bit about the structure of our configs. So Condor configs are read in a lexicographical order. You have a hierarchy of files where values that are written in later files will override the same value in a previous file. And this gives you a lot of power. So this graphic over here is a depiction of our site. Our site has many pools. Each of our pools has central manager, some number of APs, some number of CEs, and some number of execution points. So what we do is we have a site-wide configuration. This is where you want to gather everything that's common to your site, everything that all of your Condor pieces have, you put it in your site configuration. Moving down, we have a pool-wide configuration. This is where we gather things that are unique to the pool and different from other pools. Things like, who is your collector? You know, that would be in your pool config. I added this extra layer that we didn't have before. This is kind of a type-specific layer, and this is where we gather configs that are common to a certain type of Condor node, but irrespective of the pool. So things like, in this example, our CE, all of our CEs have the same daemon list or things like that. So we would put that on a config of this level. So
I must say that it's rewarding to see how a simple, basic idea that was implemented, God knows how many decades ago.
Yeah.
You know, we always believe that configuration should be a hierarchy of files with the latest value overriding. It, by the way, is true for other parts like the class add and things like that. And here, all this time after it was first implemented, it proves to be useful.
You guys nailed it the first time. I mean, this is great. I use this to the fullest extent.
And as we talk about all the need for change, it's key that we integrate this concept in the way we structure everything that we do, understanding that it's tomorrow, who knows what we will have.
Yeah, exactly.
And I would like this to be a message that we all take with us leaving here later today.
Yeah, of course. And this being the last talk, we can, you know, drive that point home, hopefully. So to finish up, the last layer that I considered as its own layer is a type-specific, pool-specific config. So this would be where, for example, on your EPs, you might have a custom start expression for your pool that's different from other pools. You know, it would live there, for example. And the idea here is you want to configure things at the highest level of commonality. And then if you do this right, anything that you want to change will be exactly where you expect it to be if you can think of the scope of what the change you're looking for is.
This is the fundamental of a type system. Again, an idea that is A, and there is inheritance, but there is overriding as you go down in the hierarchy of types.
Exactly.
So this is just another sort of example of this fundamental concept.
Yeah, and I didn't include it in this talk because I didn't want to get too far in the weeds, but I rewrote all of our Puppet code to, you know, all of our Condor-related Puppet code, and I structured it in a very similar Condor-like way because my idea is if someone's changing the Puppet code for Condor, they're trying to do something with Condor, so they're a Condor admin. So I wrote the Puppet code with Condor administration in mind. It's not written for a Puppet guru, it's written for a Condor admin. And same thing with our form and host group structure, very much mirrors our pool structure. You know, we kept everything consistent across the board. And that was an important idea. Some more operational improvements. I cooked up this Python wrapper program called HTCTL for use at our site. It's loosely inspired on the HTCondor noun verb idea, which I liked a lot. And this provides some quality of life and additional functionalities that are common things that we do at our site. And we wanted a short way to wrap it or maybe make it a little bit more powerful. So it's context aware. So based on where you're running it, you kind of get the noun part for free. And if, for example, I do an HTCTL start on an EP, it does things like pre-flight checks. You know, it's checking are all of our file systems that we're expecting mounted? And if not, it won't start the EP. It kind of gives us a little bit of a protection. We can disable EPs with a message. This is probably familiar to people that do like a Puppet agent disable with a message. So I kind of stole that idea and put it in here. And I also added some weird advanced features that are not present in normal Condor. So this idea of being able to back up the queue of a running AP, blow it completely away, maybe rebuild its operating system, restore the queue, and no one will know anything happened. So some restrictions apply. There's a very tight time window involved in that operation, but it is possible. So, and I added some alternative draining options, which I'll talk about in a second. Well, if you like it, I'm happy to do it. So naming things is hard. I just cooked up this name last night because I needed something to call it. So I called it Condor Wacky Draining. And this is some maybe not fully endorsed draining paradigms, maybe slightly cursed draining paradigms, but we use them anyway. So I have this vacate drain. My vacate drain, the observation was in a steady state pool, young jobs are more likely to make a drain take longer. That may or may not be true on a node by node basis, but this is a numbers game. So in the aggregate, that kind of holds true. So the implementation here is we perform a graceful drain of the EP, but you immediately vacate any job that's younger than X amount of time where X is configurable. Just get them out now so they don't waste more time idling the node later. And then we also have this like good enough drain. So the observation is most jobs that we have, they drain pretty fast on the order of a couple hours, but the drain follows this logistic curve with a long tail. So a few jobs seem to stick around forever on the order of many days. This becomes very wasteful because you have one or two slots holding up the entire EP doing basically nothing for days at a time. So the implementation here is you perform a graceful drain, but you declare a certain percentage good enough and you just kill everyone that's left. So when I was cooking this wacky drain stuff, I could hear in the back of my head Marone saying, jobs are money in the bank. And that's true. A job is a sacred thing and we should treat them with respect. So wacky draining your EPs, it's not a one size fits all solution. It's not really intended for use on our shared pool with lots of like unrelated users, but this becomes very attractive on our dedicated pools where the victim is often the same as the beneficiary. So using the jobs or money in the bank analogy, this is like, give me $10 now and I'll give you $100 later today when your EP is back up and running. So it's a good segue into this thing. I didn't make this. This was made by my colleague Oscar. So thank you, Oscar, for cooking this. This is intended to speed up and remove the human element of our operating system rebuilds. Basically, this is a Jenkins workflow or Jenkins pipeline, I think is the right nomenclature. We go to this page, we set up a hostname filter of all the hosts that we want to rebuild. These are EPs. We specify a desired operating system version with a validation string so we could check to see if it worked. And then a configurable batch size. So the batch size is effectively a concurrency limit of the amount of EPs that we want draining at any given time. And this pipeline will hold that number at the batch size as nodes finish their work, finish their drain, rebuild, come back, re-enter the pool, it'll start draining the next one. You just set this up and you run it and you walk away. Further down the page, which I put on the right side, there's some checkboxes which you can configure how nice or how wacky you want your drain to be. So we can do a completely graceful drain. We could do a completely violent drain where we just pass drain everything, or something wacky in between with our configurable parameters on there. So effectively, we want to rebuild our pool. We fill out this page. We click a green button. We run away as fast as possible. This was back in February. This is our big pool. This is a pool with about 1,200 hosts. We were targeting a batch size of about 10%, so I think we used 120 hosts. This is the CPU and memory graph. At the time, the pool was memory constrained, so you can see it's full, but the CPU graph shows the capacity a little bit better at the top there. So when we kicked off this pipeline, the capacity drops immediately. Those nodes are on the pool, but they're draining, so they're not considered capacity. And it kind of holds it at that level continuously with some variation. And at the end of 10 days, our pool is back up to full strength. And we didn't really do anything more than just fill out a page and click a green button. So thank you, Oscar. It's an amazing tool. Definitely check out Jenkins. So some monitoring. So to improve something, you first have to quantify it. And this is a hard problem sometimes. So within the last month, I've been working really hard on setting up ad stash at our site. We have Condor ad stash, which will take all the terminal job ads, send it somewhere. This could be Elastic or OpenSearch. Since for us, the right price is $0, we're using OpenSearch. And here is, well, you can see the FBI got to the BNL files and redacted everything, but each one of these records is a full job ad. You could see in the last 14 days, we have like 11 million of these. So it's kind of like drinking from the fire hose. There's a lot of power here, but what do you do with all this data? So of course, we use OpenSearch as a data source for Grafana. We want to feed this stuff into something where we can look at it. And these are obviously a work in progress because Grafana is not in dark mode. That's been a theme during this conference. It's dark mode, it's good. But this is just a snapshot here. I have some filters at the top where we can drill down by user or maybe accounting group or both. In the top left, we have a depiction of job count. This is completed jobs and removed jobs in 1 hour buckets. In the top right is just a simple count of the same. Jumping over here to the bottom left is the the removed jobs broken down further by vacated reason code. Sometimes that's interesting to know. And the most interesting graphs here, though, are these two graphs in the middle. So this one on the left here is the 1 hour average of memory usage versus request memory. And this allows us to get kind of a vibe of how good are their memory requests compared to what they're actually using. This plot over here on the right is a ratio of that. So we're taking the memory usage, we're dividing it by the request memory, multiplying it by 100, and just gathering them in 1% buckets. So you can see here, there's kind of almost like a Gaussian distribution around like 75%, which 75% doesn't sound amazing, but for me, that's actually pretty good. It could be a lot worse, trust me. So oftentimes, and this was brought up probably several times yesterday, you could run into a situation where you have a memory constrained pool. You have all these CPUs sitting on the floor waiting around, but they can't schedule any more work because the memory is all spoken for. And as the pools get larger in size, this could be a significant problem. So here we have a memory constrained workload, and this amounts to about 30,000 CPUs just kind of waiting around doing nothing. And that's significant. So this begs a couple of questions here. I have loads of idle CPU, but no memory left. Are we making good memory requests? Maybe. Can we do better? The answer is almost certainly yes. You can always do a little bit better. So this is a flashback to Todd's talk of lies from last year. I grabbed this slide directly. There was this idea of a multiple memory request. And this is a really powerful idea when your pool is memory constrained. So a lot of jobs use some amount of memory that could be variable. And a lot of times we're seeing jobs where most of the jobs would finish within a certain memory, but there's a couple outliers that require a bit or maybe even significantly more. And the way users handle that is they don't want to micromanage stuff. So they just ask for the big amount for all of their jobs. This can be a little bit wasteful. So in a perfect world, you can request at a first pass an amount that's big enough to accommodate most of your jobs, almost all your jobs, and then a second request that'll accommodate everything that is too big to fit in that. Now, figuring out these values is actually the hard part, but it is possible. And there's lots of ways to do multiple memory requests. You could do a list, kind of like the last slide. You could do, a bunch of different ways here. I'll just leave that as an exercise to the user because we're probably maybe running a little shorter on time. Now, some people, a lot of sites don't have ad stash. What if you want to explore your memory usage anyway? Well, you can actually just drink directly from the fire hose. Condor history is very powerful. It's very feature rich. The -AF flag is really powerful. If you're not using -AF, you have to start using it yesterday. So here I just cooked up a query. I gave a constraint specifying a user that I'm interested in. And my auto format, which is tab, the T is for tab, the J is for job ID. And then I'm giving columns of our memory usage, our request memory. And you can also do really interesting things. You can do some math between these. So my last column is a ratio of those two things. I multiplied by 1.0 because if I didn't do that, it was doing integer math and just making a bunch of zeros. So here you could see these are pretty good memory requests. 70% is not too bad. It could be a lot worse. And this output is really nice because if you're a Linux wizard, you can pipe it directly into awk, grep, sed. You could do all kinds of crazy things with it. Maybe you hate the command line. You can output this to a file and ingest it into something like Excel or Google, whatever the Google thing that Excel has. Yeah. To finish up, this is my last slide. It's very, very dense here, so I'll try to make it a little easy to palate. Some R&D at our site. So to hyperthread or not to hyperthread, and why is this even a question? Well, we live in kind of this weird world right now. The fact of the matter is memory is really expensive. It's a huge fraction of the cost of servers these days. So if you're purchasing servers or you're looking at a hardware refresh, you might want to start looking at things like this. So we found that based on our workloads, hyperthreading provides at best about 130%. This is at best 130% throughput compared to the same system with hyperthreading off. Usually it was somewhere around 120%, something like that. But we were finding that if we want to reach a certain memory per core or memory per logical core, when you hyperthread your system, you need to buy twice as much memory. And this is pretty much doubling the cost of the servers. So I had this weird idea. I was like, well, what if we half the memory? What if we turned hyperthreading off and just bought twice as many servers? Kind of a crazy idea that would not have worked a couple of years ago, but it might work here. So don't take my word for it. Get quotes yourself, try it both ways. You might actually be surprised at how weird things are lately. We're playing with this idea of CPU oversubscription on one of our pools. We noticed that some workloads, this is definitely not a one-size-fits-all thing here. You probably don't want this, but some workloads spend a decent amount of time idling CPU while waiting for files. So we're thinking, what can we do to increase throughput? Well, we can lie to Condor. We can tell it has more CPUs, and it will receive more work. I haven't quantified this yet, so I don't have anything interesting to show you. We expect the gains, if any, would be marginal at best. But with the size of our pool, a marginal increase is actually significant. If we can increase our throughput by 1%, that becomes serious when you're delivering, over 4 million CPU hours of compute per day. We added this extra thing, electrical power-based rank and other things. So our EPs, they already have access to our power data. We can add it to the machine class add with a startd cron. I started using startd crons. They're great. Definitely check them out. And we had these ideas where you can set a machine's rank based on the power usage of, say, the server row. If we have one server row that's using a lot of power, another one that's using not so much power, we can make Condor aware of that and send jobs to the less utilized row to even things out. So it's an idea we're playing with. We can also set a maximum power ceiling for our site. You know, we can say if we're using more than this amount of power, just stop accepting jobs. That's not super interesting for us, but that might be interesting to other sites, maybe Europe, where power is a little bit more expensive or harder to get. And to finish off, AI is pretty hot right now, so we're looking at some AI stuff. So logs monitoring, anomaly detection, you know, could you say, Chad, are we cooked? And it tells you about your condor farm? I don't know, maybe. So any thoughts on that are appreciated. And that's it. I just wanted to thank, of course, my team, you know, a bunch of people to thank, and a very special thank to TJ. You know, I work with TJ very often, and he helped me throughout this whole process. So the Condor team is amazing. TJ is great, so big kudos to him. And I'll take any questions.
Is there a reason why the cat picture is next to your thanks to TJ? Should we
I don't know.
should we reach any? You don't know. I don't know either. But
That's between you and TJ.
So how many people caught in his great example of using
Which one?
Condor history with minus AF?
Yeah.
Yeah, that he used the magic :TJ option
Yeah,
after.
it works better than JT because TJ.
Yes.
So
Questions? We have a bunch of hands up.
Is it open? Okay. So now I wanted to comment on the Condor restructuring of the configuration, and I wanted to first of all congratulate, because this type of work that is tedious,
oh yeah.
and you don't get any reward for it. The reward you get is maybe breaking things and pissing people off.
Yeah, exactly.
So yeah, congratulations. That I wanted to ask you, how much time did it take, and if you had any strategy to make sure that you were not breaking things, maybe testing one change at a time or testing it in a test bed? Or
Okay, yeah, that's actually a great question. I didn't include it in the main slides, but I might have a bonus slide that addresses that. I didn't include that bonus slide. So anyway, most of our code, all of our code here is in Puppet. So you know, if you're using Puppet, this is easy to translate, but if you're not using Puppet, you can use a lot of the same ideas. So all of our code was under a Puppet class called Condor, which is something we wrote ourselves. And when I was approaching the refactor, I thought about, well, I want to make it so it's easy to change, easy to fall back if things go wrong. So I created a new Puppet class called HTCondor. So my rewrite, kind of following these guys, it's not called Condor, it's called HTCondor. All of the new code exists in a separate place, and actually both are still production worthy. I didn't break the old stuff, I just made the new stuff as kind of a greenfield deployment. And if I go back to our 3 pools, we're actually in the middle of a transition right now. So our US Atlas Tier 1 pool is using all of the new code, and our other 2 pools are still using the old code because it still works. This was a really important design decision because I was like, well, if it doesn't work, I could just rebuild the nodes that I touched into the old code and I'm still fine, and that gives me time to tweak. And it also allowed me to build a test pool in the new production, whereas my real production was using old production, and move along that way. So I started this back in probably October. Actually, I might have that. I don't have that on the slide either. So I started this back in October, and I don't have a lot of time for development, so this was kind of done in my spare time.
So on this slide, you have what, over 50 APs?
Yeah, on the order of about 50 APs and CEs all combined. Yeah.
Okay. And the shared pool has a lot more APs. Is this like access to users' local data, or what?
Yeah, so we kept our APs kind of segregated by experiment. Each experiment has at least 2 of them for redundancy. Some have as many as 8. And that was done intentionally because, the certain users can log into some but not others. If they're related to that experiment, it's their resource to use. And also, at worst, you can only hurt your colleagues who can, you know, attack you. You can't hurt people from another experiment or organization.
Todd, I would like mentally to think about the CEs and the APs as close cousins.
Yeah.
Because the CE is an AP.
Yes, exactly.
So you have another 8 there that should be counted as APs. They're just not driven by humans, but driven by other agents.
Yeah, no, of course. Our CEs are kind of like children's of the AP, but they just have this extra weird thing.
Right. They're weird. Yeah. I wonder for this question about moving from one configuration to the other, can we develop a tool that that does a diff between configuration? So basically, the Condor demon wakes up, and all it knows about the world is from the configuration.
Right.
So will it make sense to give a Condor daemon, here's this configuration, and here's the new one, here's the old one. From your perspective, what's the difference? Are they the same or are they different? I don't know if it would be useful, but that's the thought that I have.
It's an interesting idea. We didn't consider any individual. So for example, an individual EP wouldn't have both configurations, but I spent a lot of time creating one in the new, one in the old, and looking at.
But if I give you a tool, well, all it does is here's the old configuration, here's the new configuration. From your perspective of a Condor daemon, what's the difference between the world here and the world there? My gut feeling is that it can be helpful to say, as far as I am concerned as a daemon, this is the difference between these two configurations.
Yeah, so for my work on this, I was the tool and I used Condor config valve.
We may hire you as a Condor daemon, but that's a different story.
That's I'm a daemon of a different flavor. So a tool that was very useful, and if you don't know about this, you should check it out, is the Condor config file -summary, which TJ taught me about. And that will show you things, it digests your configs and only shows you things that are different from the defaults. So I took our old config, I would digest it with Condor config val summary, and that took our huge old configs, but left out all the crap that doesn't even work anymore, is same as the default, and that just gave me the stuff that I cared about. And that was the basis for creating the new config.
Yeah, okay, so maybe it's almost there.
The tools kind of already exist.
Okay.
What's up, Cole?
First, I want to say great talk, a lot of hidden gems all over it.
Oh yeah, I'm happy to expound on anything.
But when you're talking about the HT control command, I think a lot of the CHCC team is like, we should have that for sure. But B, you said it was inspired by the HTCondor CLI tool that we have developed.
Yes.
And I was curious if you would be interested or think it'd be beneficial if the HTCondor tool was extensible in a way where you as an admin could develop nouns and verbs for you as an admin or your users that just ties in to HTCondor like automatically via config or something.
No, that's super interesting. I'm always interested in getting rid of bespoke things, and I love first-class support for things. I begrudgingly wrote this because this adds technical debt. This is obviously something that needs to be maintained. It exists. I wrote it. Someone else maybe can't maintain it. My dream for this is eventually Condor will do everything that this does, and then I could just get rid of it. So yeah, of course.
We take pull requests.
I'll have to check it out, you know. Well, exactly. So there's no nouns here because the noun is based on where you are. It's contextual based. This is not designed to be run from somewhere to do something somewhere else. It does something to you, and it does something slightly different based on where. So for example, this has actions for EPs only. If you tried these verbs on an AP, it just doesn't let you. It says you're an AP. This only works on an EP. So there's
Now that means like this host.
yeah, me. Yeah, the noun here is me. Exactly.
Brian, do you have a
Yeah, I
Yeah,
had a
Brian.
question about your Jenkins reprovisioning setup. I'm
Yes.
wondering how much, could you go to the next slide, actually? I'm wondering how much heterogeneity you have to worry about in the pools. Do you use this in your shared pool? Do you have to worry about all the different types of workflows and experiments? How much heterogeneity in hardware do you have?
Yeah, so this works really well for all of our pools. The key here is these optional things. So for our more unified single user pools, we can do things like wacky drain because you're hurting one user, but you're also helping that same user. That idea doesn't hold water necessarily on our shared pool. Our shared pool, we would be much more conservative and maybe just do a straight graceful drain. When we graceful drain it, it's completely users won't even notice. There will just be a reduction in capacity, which is configurable. You can make your batch size really small, but your upgrade takes a really long time. Likewise, you can make your batch size really big and shorten that, but users will notice if the batch size is really big. So yeah, you can make this basically as transparent as you like, depending on how long you want to take.
And how easy is it to find when things go wrong? Like nodes don't reprovision as you expect.
So that would be a better question for Oscar, but I've seen a little bit behind the curtain, and this thing outputs a lot of data. There's basically cron outputs that we can look at, which shows, I wish I included in the slide. It shows basically a list of all the hosts and which stage they're at in the pipeline. So you can see when hosts get stalled, maybe it's worth checking them out. We also have monitoring, if a node reboots to rebuild but never shows up again, we have other monitoring to catch that. So it's really easy to find when things go wrong.
Cool, thank you.
Yeah, no worries.
Okay, thanks. One more round for Tom. Thank you. Good job.